All right, we're starting 8.1, and 8.1 is more with quadrilaterals, but this first section is with polygons in general. So this is finding angle measures inside, or I should say around polygons as well. So first vocab word, here's the diagonal, a segment that joins two non-consecutive vertices. Okay, non-consecutive, consecutive comes one right after the other. So a non-consecutive means a vertex that comes after a different one, but not the one beside it. So to start with something like a rectangle, and here's a vertex, here's a vertex, here's a vertex, and here's a vertex. So if I want a diagonal, I can't take this vertex number one and go to the one beside it to the right or to the bottom because those are consecutive. So a diagonal goes from the first one over here across to this one that's not consecutive. Okay, there's only a possibility of two diagonals in a rectangle. If you think about a triangle, because there's only three to start with, every vertex is consecutive to the other one, so you can't draw a diagonal, okay? But the more sides you put on a polygon, the more diagonals you can draw, okay? That one's non-consecutive there and there. That one's non-consecutive to there and there. This one's non-consecutive to there and there. So we end up with about 1, 2, 3, 4, 5, I think, on that one, okay? All right, so let's go through and start with our first theorem here about the polygon's interior angles. And this is important to know that we're inside because there's different rules for different ones. These are interior. And another thing I want to make sure we know is we're working with a convex polygon. Convex, all the sides are on the outside, nothing caves in. If you have things cave in, the rules do not apply to it. So this is interior angles of a convex. And one thing I'm putting here on the side to make sure we know is n is the number of sides of a polygon, okay? So when you see this n used, and it does get used frequently in math, more in geometry than other ones, it almost always means the number of sides, okay? So when you see n, it's the number of sides. So the sum of the measures of all the interior angles of a convex n-gon is n minus 2 times 180. So the measure of 1 plus the measure of 2 plus however other angles there are is going to be the number of sides minus 2 times 180. That's when I add up all the sides inside, okay? Now, where do we see or hear 180 most of the time in geometry? It's the sum of the angles inside of a triangle. Okay, so let me see if I can draw you. I have a pentagon here, 5 sides. If I draw from one vertex as many diagonals as possible, and it's from one vertex, not from all, but from just this one vertex, I end up with 3 triangles, okay? So I have 1, 2, 3 triangles. So I can take 3 times 180, and it would add for me all these angles all the way around, okay, because it would take care of all the angles inside all these triangles. And all the triangles have 180, so if I add all their angles together, I get how many are inside that pentagon, 3 times 180. Well, how many sides are on a pentagon? 5. 5 minus 2 is 3 times 180. That's what this formula does. It basically is saying how many triangles are in your polygon, n minus 2, so your sides minus 2, and then times 180. All right, so just kind of a corollary, this is saying if we already know this from the theorem, what can we get from there? So our corollary to the theorem says that means that anytime you add the interior angles of a quadrilateral, it will always be 360, okay? Because there's 2 triangles, okay? Remember, if I have a quadrilateral and I draw from one vertex over, I get 2 triangles, and that creates 360. Every quadrilateral's interior angle, as long as it's convex, will add up to 360. All right, in the margin here, I have a little chart here. Just a quick reminder, as this vocab appears, you're responsible for it. You need to know it. If we're talking about anything with 3 sides, it's a triangle. Anything with 4 sides, and the most generic term for 4 sides are quadrilaterals. A 5 side is a pentagon. 6 side is a hexagon with an X, 6 and X. Hex. 7 is a heptagon, starts with an H as well, heptagon. 8 is an octagon, 9 a nonagon, 10 a decagon. We've talked before how we skip 11 here because it's not something we see a lot of, so you don't have to have a special name for it. 12 is a dodecagon, using the do for 2 and the decagon for 10. And all the rest we're just going to call n-gon. So if it has 12, or if it has 17 sides, it would be a 17-gon, okay? You don't have to spell out the word 17. You can write the numbers -gon, okay? Excuse me. Let's look at our example over here. Find the sum of the measures of the interior angles of a convex hexagon. So hexagon, how many sides on a hexagon? 6. So using our formula of n minus 2 times 180, we can do 6 sides minus 2 times 180. 6 minus 2 is 4. 4 times 180, 720. So if I add all those interior angles, I get 720. Okay, on a side note, come over here to one vertex, choose a vertex. So I'm going to choose this as my vertex. Draw as many diagonals as I can in here. The first vertex is consecutive. It doesn't go, here's a non-consecutive, here's a non-consecutive, here's a non-consecutive. The next one's right beside it. So I can only draw 3, but that made 1, 2, 3, 4 triangles. There's my 4 times 180 that we got before equals 720. So if you're a visual person, go ahead and draw it. Draw all the diagonals from one vertex, not from all vertices, just one. And then you multiply that times the 180 to see how many triangles that formed. And that's the sum of all the angles inside. All right, so at the top here it says the sum of the measures of the interior angles of a convex polygon is 1,260 degrees. Classify the polygon by the number of sides. Okay, if you think about this one's actually going backwards. It tells us what all the angles add up to, but it did not tell us the number of sides. We need to figure out the number of sides so we can classify it. Okay, so we start out again, n minus 2 times 180. And when they did n minus 2 times 180, they got 1,260. Our job is to solve for n, okay? So I need to get n by itself. Right now it's being subtracted, 2 is being subtracted from it, and 180 is being multiplied by it. Let's undo them. Outside the parenthesis, get rid of that first. So I'm going to divide by 180 first. That leaves me my n minus 2. 1,260 divided by 80, that's 7. My job is to get n by itself. I still have a negative 2 or a minus 2, so to get rid of that, I do the opposite, which is add 2, and n equals 9. So if there's 9 sides on this polygon, I classify it by its sides. What's a 9-sided figure called? A nonagon. All right. For the next one, it says find the value of x in the diagram shown. And I will tell you, you're going to see a lot of these in your homework, and this is what you have to think of when you get there. So find the value of x in this diagram. I have all the angles inside this quadrilateral marked, but some of them are x and some of them are numbers. So I have to know what should they all equal. Okay. So the first thing in my steps over here, I say name the figure or find the number of sides. That's important to know, okay? So I have 4 sides, okay? Find the sum of their interior angles. Do n minus 2 times 180. So 4 minus 2 times 180. So that's 2 times 180. That means they should equal 360, okay? Just know this, whatever they equal, will change depending on how many sides on your polygon. So if you have a decagon, that number's going to be much larger, okay? If I have a triangle, it's smaller. So know that this number right here is the one that will change depending on the sides of your triangle. So I'm going to add all my angles together. X plus 71 plus 112 plus 135 equals my 360. Get out your handy-dandy calculator, unless you're a really good adder. 71 plus 112 plus 135. And that equals 318. I'm trying to get x by itself. It has 318 being added to it, so do the opposite, which is subtract by 318. 360 minus 318 leaves me with 42. So that x up there is 42 degrees. Okay. All right, let's look at number 1 down here. Find the sum. And that's important to know, not one angle, but all of the angles. Find the sum of the measures of the interior angles of a convex decagon. So 10 sides, okay? Remember, you can always go to one vertex, choose a vertex, either one, any one of them is fine, but only go to one, and draw as many diagonals as you can. The first vertex is too close, I go to the next one, the next, and I start drawing it to every one of them that is not right beside it, so I get this many. Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8 triangles. Okay, that's the same as saying n minus 2. 10 minus 2 is 8, okay, times my 180. And 8 times 180, 1,440 degrees. For inside that decagon, all those angles inside will add up to 1,440. All right, moving on to page 3. All right, it says the sum of the measures of the interior angles of a convex polygon is 1,620. Classify the polygon by its number of sides. So again, they've already added all my angles. They did the work for me. I have to go backwards to find the number of sides. So this is where I do my n minus 2 times 180. Already got me an answer of 1,620. I need to work backwards to find out what that n was. I'm going to divide both sides by 180. I get n minus 2 equals 9. I still don't have n by itself, so I have to add 2 to both sides. My final answer, n equals 11. If I'm going to classify this, there's no special name for 11-sided figure, so we just call it an 11gon. Okay, there's my answer, an 11gon. All right, still talking interior angles. Use the diagram at the right to find measure of angle K and angle L. I'm looking for two different ones, but maybe they're not so different. I notice they both have the same marking on those, which means they're both the same. I'm going to call them both X. Okay, the first thing I want to do in a problem like this is figure out what should my interior angles equal. Okay, so I count my sides. 1, 2, 3, 4, 5 sides. So 5 minus 2 times 180. That's 3 times 180, which equals 540. Okay, this is important. This changes for every question, so I need to figure that out first. So I'm going to add my angles, 68 plus 105 plus 109 plus x equals my number I just found, 540. Do the math here. I have two x's. 68 plus 105 plus 109 gives me 282. Subtract my 282, and I get 258. Divide by 2, I get 129. So each x equals 129. So the measure of k equals 129, and I did not write that well. And the measure of angle L also equals 129 because they are both the same and they both need to be 129 for all the angles in that pentagon to add up to 540. All right, so that's just generic interior angles, and remember that's the sum. We find all of them together, and when they give us individual ones, then we can subtract or do the math to find the missing ones. Let's talk exterior angles. Okay, and I have to remind you with these exterior angles, when we have a figure drawn, okay, like this, the interior angles are all these angles inside, okay? That's what we've been adding up every time. But the exterior angles are the angles outside. Remember, it's not a full angle all the way around here. It's when I extend this side, it's this angle on the outside. I extend this side, it's this angle here. I extend this side, it's this angle here. Extend this side, it's all these angles. So it's when we extend the sides, we get all these extra angles, okay? Now I'm going to add up all those angles. So on this figure, I'm adding up all those blue angles. When I add all of those together, it equals 360. It doesn't matter if it's a pentagon, a decagon, a dodecagon. It doesn't matter if there's 45 sides on that. If I add the outside angles, they will always add up to 360, no matter what. That's what this theorem says. The sum of the measures of the exterior angles of a convex polygon, one angle at each vertex is 360 degrees. You will always get 360 when we add all of those up, okay? So it doesn't matter, I don't have to count how many sides, I just automatically on the exterior angles know that they're gonna add to 360. So let's do our next problem here. Find the value of x in this diagram. Well, I see all these exterior angles. Now, what's important to know is you have to get an exterior angle at every vertex. You can't just use some of them. You have to use all of them. So I see x on the first vertex. I see 89 on the next. On the next vertex, I see a 2x. And finally, on the last one over here, I see an 85. All of them add up to 360 because they're outside. The outsides always add to 360. Joining my x's, I get 3x. Joining my 89 and 85, I get 174. Subtract my 174, and 3x equals 186. Divide by 3, and I get 62. Okay, so x is 62 here. Now, just a quick side note, x is 62. That will make this angle 62 degrees, but in this case, I have to double it, and I'd get 124 degrees. So I don't want to write x equals 62 degrees, because the number x is 62. When I plug it back in, the angles are with degrees, okay? All right, one final page here to go on our notes. And it looks like something, I didn't like something there. We'll have to fix that. All right, it says the base of a lamp is in the shape of a regular 15-gon, okay? I'm going to tell you right now, I'm a terrible artist. I think I've told you that before. And to draw 15-gon is a pretty intimidating thing, okay? If you want to do that, I would suggest you make a circle of 15 dots, okay? I can't even probably do that very well, but that's kind of what you do. And then you just start joining them, and as you join them, you get sides of your vertice, okay? That's a terrible picture. I'm just going to get rid of it. But if you choose to draw it. All right, so the base of the lamp is in the shape of a regular 15-gon. And I reminded you over here in the margin, what does regular mean? All sides and all angles are equal, okay? So every angle inside that equals the same amount. It says find the measure of the interior angles and find the measure of each exterior angle. Okay, this is important. It says each. That means one of them, okay? This says each. That means one of them. So that's what I'm looking for. Okay, to find the measure of one interior angle of a polygon, I'm going to give you a formula. Remember, we were doing n minus 2 times 180, and that gave us all the angles added up inside the polygon. But on a regular polygon, they're all exactly the same. So if I take n minus 2 times 180, I get this great big number maybe. If I divide it by how many sides there are, or angles there are, I can find the measure of just one of those angles, okay? So let's try this. So I have 15 gone, so I'm going to do 15 minus 2 times 180. That means that I can get 13 triangles, right? And so I get 13 triangles times 180. That means all of them together equal 2,340, sorry. But I'm going to divide by 15 of those angles, because there's 15 angles inside there. And if I divide that total by 15, that means all of those inside angles are going to be 156 degrees. So this is for one interior angle. I'm going to get 156 degrees, okay? So I'm not drawing the whole thing, but just kind of a heads up. So that's a pretty big obtuse angle here. So inside I get 156 degrees, right? Then the next angle is the next, and that's going to be 156, the next one. Do you know the more sides you get on a figure, the more it starts looking like a circle? Okay? I don't know if we talked about that once before when we talked about 11 gon. That's what the Canadian coins are. Most of us think of those coins as being circular, but they're not. They have 11 sides. And if you think about that, the more sides you get on things, the more it starts to look like a circle, okay? So 15 sides, definitely starting to look like a circle. Okay, so my interior angle is 156. Now let's talk about the exterior angles. So if we think about it, to find the measure of an exterior angle, we know that we have 360 for all of them. We don't have to figure out that number because it's the same every time. And then we're just going to divide by how many sides there are, okay? That's what we're going to do to find our exterior angles. So we're going to do 360 divided by our 15 sides. All right, 360 divided by 15, that gives me 24 degrees. So this is one exterior angle is 24 degrees. Okay, quick note. Remember this exterior angle is this one out here, and it's 24 degrees. What do you know about 156 and 24? When I add them together, they make 180. Does that make sense? Oh, definitely it makes sense, because an exterior angle is the linear pair with an interior angle. So if I know one, I can just subtract from 180 to get the other, or I can follow my rules over here and the same thing applies. Okay, so let's look at this question here in the margin before I move on. It says each exterior angle of a regular n-gon has a measure of 45. Classify the polygon by its number of sides. This kind of looks similar to what we saw earlier when we were just figuring out what the angles, how many sides there are. We're going to do it this time with an exterior angle one, though. Okay, so let's see. Each exterior angle of a regular n-gon has a measure of 45. We'll define one exterior angle on a regular n-gon. I use that formula 360 divided by n. And this time I got an answer of 45, so I need to work backwards to find out how many sides there are. Well, I can't solve for n when it's in a denominator, so I multiply by n to get it out of the denominator. These two cancel. 360 degrees equals 45 times n. I'm going to divide by 45 degrees on both sides. 360 divided by 45? 8. That means there's 8 sides here. What's my polygon's name? How about an octagon? Okay. So working our formulas backwards, or what we need to do backwards there. Remember, exterior angle always has that 360 divided by n. Makes it super easy to do what we need to do on that one. All right. A convex polygon has exterior angles with measures of 66, 77, 82, and 62. What's the measure of the exterior angle at the 5th vertex? Okay, pentagon, 5. 1, 2, 3, 4, 5. The outside angles add up to what? 5 sides. What do all the exterior angles add up to? It's got to be 360. All of them add up to 360, no matter how many are on the outside. So I start filling them in here. 66, 77, 82, 62, and we don't know our last one, so there's my x. All right, little algebra here. X is the only variable. When I add 66 plus 77 plus 82 plus 62, I get 287. 360 minus that 287, I have a missing angle of 73 degrees for that outside angle. All right, for number 5, find the measure of each interior angle and each exterior angle of a regular n-gon. Not n-gon, I'm sorry, nonagon. Nonagon has how many sides? 9 sides. Okay, remember, each is 1, and this is for a regular n-gon. Each, okay, so 1. So for A, when I'm finding my interior angle, I'm going to do my n minus 2 times 180, find the total, and divide by how many sides there are. So I have 9 minus 2 times 180 divided by 9. Okay. 9 minus 2 is 7. 7 times 180. 7 times 180 is 1,260. You divide that by 9, and I get 140 degrees. So that's for my interior angle. One of them equals 140. Remember that 1,260 was all of them divided by 9 angles, so I get the 140. All right, for my exterior angle, the math is so much easier. It's just 360 divided by n. So I do 360 divided by my 9 sides, and each exterior angle is 40. Sorry. Quick check. What does 140 plus 40 equal? 180. So that makes sense to us that those two angles are the interior and exterior angle of a regular nonagon. All right, So you're turning in your book to page 510 to 511 to practice what we've learned today. Quick note on number 13, okay? Just want to give you a heads up. On number 13 in your book, the drawing is not accurate, okay? They label 1, 2, 3, 4, 5, 6, 7, 8 angles, but they only show 7 sides. There's a problem there, okay? So to keep us all accurate, why don't we all say that on number 13, there's 8 sides, okay? Because there's 8 angles and 8 sides should go with that. So think of that figure as having 8 sides, and that will help you on number 13, okay? If you have questions, please let me know.